Ohm's Law. So we're going to use Ohm's Law to calculate current, voltage, and resistance. Let's have a closer look at this LED. This LED needs two things to operate. It needs current, and it's getting a current of 19.4 milliamps. Let's call that 20 milliamps. And voltage. It's getting a voltage of 2.19 volts. We'll call that 2 volts. Okay, so we're just rounding down. So it needs voltage and current to operate. Now, how do we calculate those things if they're not given to us? Okay, so this is the Ohm's Law formula here, where we have voltage, I for current, and R for resistance. And we can find any one of the elements in that previous circuit by just covering whichever one we're looking for and working out the formula. So I'm looking for R, I cover the R, and I'm left with V over I, or current. If I'm looking for V, I cover the V, and we're left with I multiplied by R. And if I'm looking for I, or the current, I cover the I, and I'm left with V divided by R. Now, let's work out the formulas. So in the previous circuit, if we were looking for the resistor, we would say R is equal to 9 minus 2, which is the voltage of the LED, divided by 0.02, which was the current required for the LED, which will give us 350 ohms. If we were looking for the voltage in the circuit, okay, we would say V is equal to the current of the LED multiplied by the resistor in the circuit, which will give us 7 volts. And if we were looking for I, the current, we would say that I is equal to 7 divided by 350, which is the resistance, equals 0.02 milliamps. So let's go back and have a look at our circuit again. We have 9 volts, 8.98, 9 volts coming up through here. And our resistor does a very important job because it affects both current and voltage in the circuit. So after the resistor, we'll see that the voltage has now dropped down to 2.19 volts, or 2 volts. It has dropped the voltage by 7 volts. So the forward voltage in this circuit is 2. And the current remains the same all the way around. You'll also notice that after the LED, the voltage is 0. And that's our ground wire, or the negative wire, which must be always 0. But there's still a current. The current flowing around in the circuit is still 20 milliamps.